So something like this maybe. And each rod is worth a unit. So they represent units from 1 to 10. The colors are usually quite similar. Occasionally you get a purple instead of a pink, or but generally they're pretty much the same. And they are really handy for using anything from counting, maybe for some functional skill students as well, or the ones that have moved up, addition and subtraction, multiplication and division, sequences, patterns, algebra, fractions, ratio, and proportion. Now, Cuisenaire rods, I'm actually going to be using a little bit later to show you a couple of examples. They are really useful especially if you're looking at bar modeling later on, because they are so similar. Students can make the link quite easily. And you could also access them on MathSpot if you are quite good with IT, which I am admittedly not. Then we have another example, which are base 10 blocks. They're also known as Dean blocks, or multi-base blocks. They're really not very common at FE. They used quite a lot at primary school and maybe the lower end of secondary, but it's place value, counting, number sense. So they can be useful. Personally, I don't use them, but they are certainly another option if you have some students that struggle with some of the basics. I mean, I've got quite a few that struggle a little bit with place value, so I suppose that would be quite a good use for those students. Interlocking cubes. Now, I'm a big fan of these. They are also known as unifix cubes. They're usually about 2 centimeter cubes that connect either from the side or from all sides or from the bottom. You can also get them in 1 centimeters, and you could also get them in 1 inch, which is quite handy to facilitate some of the measurement activities. In this particular picture here, there is an activity, so they could put them together, and you could look at the relationship between square and triangular numbers, maybe. So they build 2 consecutive triangles, preferably right angled, and then they turn them the same way around, and the smaller half complements the larger. Sorry, the smaller one complements the larger. They are really handy for patterns, adding, subtracting, multiplication and division. They're really handy for estimation, measuring, graphing, perimeter, area and volume, and elevation. Now, I use them mainly for elevation because that's one of those things that my students find really difficult, because they can't always quite imagine what something looks like from another angle. So these are really good for those students that perhaps are not quite as visual. Counters are one of my favorites. They are, I've got some here actually. You can get them single-sided or double-sided. These ones are, one side's red, one side's yellow. They're really, really good for patterns, as you can see on the picture there, but also algebra and general problem solving. Now, I use them an awful lot for algebra, and again, I use them a little bit later on, so you can have a look if you like it. You can also use these on MathSpot, again, if you're quite IT oriented, or if you are in the position where you know, neither the college nor you really have the funds to purchase them, you could make them yourself. They don't necessarily have to be round. They could be squares. Again, laminated like these, and you could use them. There's always a way around it. I think money is going to be a problem in most of e-colleges, so sometimes we just need to be a little bit creative. Okay, so another one. The next slide, probably you're all quite familiar with these manipulatives, and sometimes people just not don't necessarily think of them as manipulatives. So fractions discs, tiles, or strips. So I've got some fraction discs that I use quite a lot. I also use quite a lot with my students fraction strips. So you can get them anywhere on the internet, or you can create them yourself. And my students cut them up, and then we manipulate them. We use the strips as well as the discs, like on the picture on your screen, quite a bit for subtracting fractions, adding fractions, dividing, multiplying, because especially with division, my students, at least, probably 90% of them come with this KFC, but they don't really understand why that works. And then they forget, is it division or was it multiplication? So I try and work with manipulatives quite a bit in order for the students to really understand why that is and not just accept, well, that's how it is. Dice, now you probably all already use them, so anything from kind of a normal six-sided dice. I use these quite a bit for non-calculator skills. I use them for probability. I use them for all sorts. So there's tens, there's units, there's hundreds. You know, I mean, there's all sorts out there. There's positive and negatives. There's addition and subtraction and multiplication and division dice. I use them mainly for probability, but also from time to time just to change it up a little bit. I use it to practice their non-calculator skills, which tend to be a little bit on the weaker side, I must say. I'm pretty sure we're all in the same boat on that one. It's quite interesting because they don't really like doing the worksheets. They get a little bit annoyed with it. But as soon as you add a little game in there, they're quite happy to go on. Another one that I have only recently started to play around with a little bit are dominoes. Now, I've had dominoes in my cabinet for, I don't know, 15 years probably. And they only ever came out in order to fill a gap somewhere or maybe do some adding or multiplication, but never really thought of how I could use them in any other way. So I started playing around, and they're actually quite handy for triangular numbers, for those magic squares, for addition, multiplication, column addition, comparing fractions, fraction manipulation. So here, for example, if you arrange your dominoes in a kind of staircase pattern, you could have a little discussion about triangular numbers, maybe. And the squares, so for example, the ones that you've got on your screen there, it's you could do, if each row and column have to add up to the same total, can you complete the following diagram using only the dominoes shown below? Now, the reason my students don't mind doing these so much is because if they think something's wrong, they can move it quickly and they don't get embarrassed. Whereas once it's written on paper, some students haven't quite got the resilience yet to accept, well, I didn't get it right this time, so next time maybe I will. So it's a nice way, especially at the beginning when you first get to know them and they're not too sure about you. For them to warm up a little bit and maybe see, oh, actually, if I get that wrong, I can just move it around a bit. So then a couple of other possibly quite familiar ones are pattern blocks. Now, pattern blocks come in all sorts of materials. I've got some wooden ones, and they're basically for kids to make shapes. So these are little wooden ones. The reason I went for wood is only I had some foam ones and they got destroyed. So I now have wood. It's a little bit harder to destroy. They usually have an equilateral triangle. I tell you what, I bring the picture up so you got a bit of an idea. The triangle is usually green. There's a rhombus, which is the size of 2 of the triangles, which is usually blue. There is a beige rhombus. Where's that one? There's a little beige rhombus there. Look at that. Um, and that is the same side length as the green triangle. So they basically all fit together quite nicely. So you can see it there, maybe if my fingers weren't in the way. And then you've got trapezoid, which is red, which is the same size as three triangles. And then there's a hexagon, which is yellow, which is, again, you can match with 6 little triangles, green ones. And then there's usually an orange square. So these are really handy because sometimes my students struggle a little bit with shapes, full stop. Sometimes I use them for fractions. Sometimes I use them to create patterns. I use them for shape characteristics. I'm so sorry. So how many parallel sides, what are the angles like? I use them for angles and for symmetry. So they are quite useful. And I do have a set which is gigantic, which is a magnetic one to go on the whiteboard. They're really, really handy, and have not really caused too much controversy with some of my students. Geoboards. Now, geoboards, I think, are quite common at secondary. Not used so much in FE, and I'm not quite sure why, because they are incredibly handy. Geoboards are basically boards that have, there's a picture, that have pins in them, and then you can use either the geobands or basically just rubber bands to create shapes. They are really good for plane shapes, classification, scaling, translation, rotation, reflection. For translation, rotation, reflection, I quite like them because it's not just on paper all the time. They can play around with something physical. Similarity and congruence, counting angles, area, perimeter, they're good for all sorts. They're really, really useful resource, actually. I use them quite a bit. So for example, on the picture example that you have on your screen, using a 3x3 array on your geoboard, identify the 8 distinct triangles that you can that can be constructed. Eliminate reflections, rotations, and translations. And then you could classify those triangles according to their sides, angles, and symmetry. I do use them quite a lot. I don't use them so much with my construction students anymore. Yeah, I end up with no elastic bands, unfortunately, at the end. But all other groups it works really well with. So these are really, really handy. And I think if you could buy anything, I'd probably go for the geoboards, because most other things you could create yourself. Okay, so they're geoboards. Then we have 3D shapes, right? Folding shapes. Yes, I use them a lot as well. So again, excuse me. I bought a set years and years and years ago. It's pretty much bleached by now. But they are really useful for nets. So I've got a set here. which I can show you. I just show you one of them. The cylinder, for example. So they're really, really handy for surface area, for nets, volume, symmetry, perimeter. The reason I really like them is I've got an awful lot of students that can't always visualize nets of a 3D shape. So they sometimes really struggle with things like cones, cylinders. They're usually all right with cubes and cuboids, but some of them they really struggle with. And the beauty is they come in these lovely see-through containers, which I then use for volume. So they're multi-purpose, which is always great. Um, they're not particularly cheap, but probably one of my probably one of my most used manipulatives when it comes to shapes. Um, They usually come in the pack. You usually get cylinders, a square base pyramid, a cube, a rectangular prism, a cone, a hexagonal prism, a triangular pyramid, and a triangular prism. So there's quite a few shapes there that you can play around with. I don't have more than one sets, so what I tend to do is I kind of share them around. They can create their own nets, obviously, but sometimes I've got groups that are really not into cutting and sticking, so these are for those guys. My generally childcare groups and health and social care, they're quite like making their own, which of course is also a very good alternative. The last one that I'm going to introduce you to are algebra tiles. Now, algebra tiles are something that haven't been around and have even much, I don't think. I actually went to a different college a couple of days ago for a meeting where people just bought them and they got very excited about them. Algebra tiles are a beautiful thing for those students that struggle a little bit still with some of those concepts. Now, it can go from really, really basic to quite intricate. So I made my own. So these are basically, you always have a big square, which is your x squared. Then you have the bars, which is your unknown, your x. And then you have your little unit tiles, okay, which are your 1 unit. So I will use them later so you can see how they work for algebra. I use them an awful lot for factorizing double brackets because factorizing quadratics seems to be a real issue for even my higher threes can still struggle with it. Completing the square, they're incredibly good for. But I'm going to use them a little bit later for factorizing. So you can see, perhaps you've got some students that aren't so bad at algebra really, but struggle a little bit with the concept of or the process. So some have learned really well, others go, oh, which ones do I need to find the factors of? And then I needed to add something. So because I don't really understand it, they don't remember it very well. So algebra tiles are my holy grail at the moment for those that are so close but need those few extra marks. Okay, so I've taken you through quite a few, and I am aware I'm talking awfully fast. Sorry. um, I'm going to ask Syra to bring up the next poll, actually, because so many of you guys have said that you don't really use them very much or not at all. Having looked at some of those and looked at some of the areas that they would be useful for, would you use them with your students? And we'll have a look. what you think. So it's just a yes or no or maybe. We can have a bit of a discussion a little bit later on. Okay, we're almost there.
Okay, thanks everyone for voting. Juliane, we have 83% at yes, we have 0% at no, and we've got 17% at maybe.
Excellent. Okay, brilliant. So hopefully just the first few slides about what kind of manipulatives are out there, the fact that maybe we can create some of our own. I am still teaching full-time in FE, so I know what time scales are like and available free time. But what we have done is we've met our team quite a bit to create some of these, but we're also in quite a lucky position in terms of finances, so there were a few things that we could purchase. So hopefully already some of you are saying yes, I definitely use some, and some of you are maybe not quite convinced yet. Let's have a look at just a few examples, and I did have to keep it quite small, to be honest, because there's only so much time we have in terms of how to actually use them with some examples. Okay, so first of all, I think the very important bit to consider is you all know your groups best. So in FE, there's been a it's difficult for CPD and FE in terms of mastery and how to use manipulatives. Now you can take quite a few examples from secondary. They work just as well. I think an awful lot of you probably already use manipulatives without thinking that that's what they are. So if anybody has been teaching for anywhere, yeah, for as long as me or probably longer, there might be some of you that have done this a lot longer than I have. Some of you may remember some of the old standard units. Now, those standard units included an awful lot of pictorials. So there were sorting cards, number lines. A lot of you probably already use Tarsia puzzles. So not all of it is necessarily new to people. I think rethinking of how to introduce them maybe helped with me. So I needed to think very carefully about which group I can use what with, because they do differ. You know, I have a group of construction lads. Elastic bands are not a good idea with these guys. However, they really liked using 3D shapes. So on your screen, you should see these this picture of these wooden shapes. Now, these are the ones, and they were actually made by my carpentry students, which is very nice of them. We wanted some 3D shapes that we can use, and they've just made them as part of a project. So if you're in a vocational college, certainly worth an idea. You know, we can't always purchase everything. The money just isn't there. An awful lot of us already spend a lot of money on things like pens and pencils that really there isn't much left. So really what I'm trying to say is when it comes to manipulatives, have a little think, be a little bit more savvy. Maybe you can use, like I said, other vocational areas to create things, make things yourself and work as a team. We do get together quite a bit to create things like Tarsi puzzles or algebra ties. So no further ado, let's skip this bit and go straight on to linear equations. Now, an awful lot of our students come to us when it comes to solving linear equations, and have been taught the scales. You know, if you take something off one side, you need to take it off the other to balance it out. Now, there's nothing wrong with actually using actual scales for those students. So, for example, here we've got 2x plus 4 equals 10. And just the x is represented by a little bag, and the 10s are little weights. You just want the bags on one side, so you take the weights away. Well, what happens if you take the 4 weights away? It'll tip because there is now too much on the right-hand side. Then we take them off the right-hand side, so they're now even. But then we're saying, well, we don't want to know what's in one bag. We will in two bags. We want to know what's in one bag. So you halve both. Okay. Now that's something that's quite familiar to most students and most likely you. So I have expanded that a little bit, and we are firstly looking at something similar but using counters. So in this case, we have cups, and I tend to use these little espresso cups quite a bit. They're really handy because they're quite cheap and you can reuse them a million times. And counters. Now, the counters, if they're double-sided, the yellow side will be a positive and the red side will be a negative. And I do that quite a lot with my students straight off. So right from the beginning, they always know yellow's positive, red's negative, because it helps them in the long run. So in this case, the cup represents the m and the numbers are represented by the counters. So we've got m plus 3 equals 5. Now, because my students need to understand the negatives and the positives, we use the negative counters to represent the inverse operation. So if I want to take the yellows away on one side, I need to add the reds, and it will become clear in a minute. You could not worry about that when it comes to positives, but in the next example, there will be an m minus something, and then you kind of need the inverse operations. So I try and use them all the time. So the next step then is to remove the 0 pairs. So where you have the same amount of yellows and reds, there's 0 pairs, you take them out, and then you're left with m equals 2. Okay. Please let me know if I'm going a little bit too fast, and I will slow it down. So I have got another example of these with slightly different numbers. It's quite a simple one again, but this time with a negative. Okay, so we have z take 2 equals 8. So our cup again is our unknown, and minus 2 is represented by 2 red and plus 8 by 8 yellows. Okay, and this is really where you need the kind of inverse operation part. So whether you use them for the pluses is really up to you. But I like to do the same thing so my students don't get too confused. So here we want to get rid of the 2 reds, and therefore we will use the inverse operation on the left-hand side and add the 2 yellows. If we add them on the left, we need to add them on the right, and then we take away our 0 pairs again, because minus 1 plus 1 is 0, and we end up with z equals 10. Okay, so these, you can use counters, you can, what I use quite a bit, actually, are just pencils, colored pencils. I've got 100 of these things, so I use them for algebra quite a bit, especially if I have quite big groups and I don't have enough counters. Be creative. You could use anything. You could use pens, pencils. We've got some plastic play money. That works too. Post-its, anything really. Okay, so the next bit is the bit that maybe some of you will find quite useful. So algebra tiles. Now, just before I start, I think I forgot to mention this earlier, sorry. When you buy these, they do come in different colors, but usually there's red ones, or the backs are always red, which represents the negatives. So I made these in blue, green, and yellow, but then I used just whites for the negatives. So just in case that's something that you're thinking about, if you purchase them, you already get them. If you make them, you need to make sure they've got the minuses. So let's have a look at factorizing x squared plus 5x plus 6. So first of all, you need to collect all your tiles. So you have your x squared, which is your big square, your 5 lots of x's, and your 6 lots of units. Okay. So once you've got them, you then basically arrange them into rectangle. Now, what's really important is that the area of these tiles always makes a rectangle. For solving the square, obviously it makes a square, but factorizing always a rectangle, and sometimes you need to manipulate it, sorry, a little bit, because it might not work the first time around. So you need to especially if you as a teacher start playing around with them to start with, just kind of play around with it. It will make sense once you're used to them a little bit. So once you made the rectangle, you then basically label the sides. So on your screen, you should see you've got your big X squared, which is an X, and then plus 3, and then you've got an X and plus 2. Hopefully that makes sense. For those of you that like the idea, there is so much out there. There's examples on the internet. There is quite a lot of NZM stuff. There is videos. There's all sorts out there. So please, please, please have a play around with them. You will find your students will move forward quite a bit. Mine have jumped since I've used them for factorizing. It suddenly makes sense to them. And those students that seem to be a little over-reliant on the manipulatives, what I tell them after a while is, well, okay, well, you won't get them anymore. What you need to do now is, if you need to draw it out, others go straight to, well, I can kind of see it in my head. So they do it that way. So, but they have helped to kind of bridge that, oh my God, no, I can't do those. And has allowed my students to have a bit more confidence, which is quite important with quite a few of ours, because you know, they've probably done this a couple of times by now, and they've lost their confidence maybe, and they just need a little bit of a helping hand. So moving on, you can also use them for expanding. I don't use them so much for expanding because some of my students found it a little bit more confusing than the factorizing, and they tend to be okay at expanding. But basically, your first step on the left there would be arrange your tiles. So you've got your 2x plus 2 and your x plus 3. And then you basically fill it in. So you would fit a square in there. Oh wait, you can fit another square in there. Then you use your x's to fill the bigger gaps, and then the units to fill the smaller gaps, and voila, you've got 2x squares. And then you've got 1, 2, 3, 4, 5, 6, 7, 8 x's, And then in the corner on the bottom right, you have 1, 2, 3, 4, 5, 6 units. Okay. Again, it's something that you need to get used to if you haven't used them before. But as I mentioned earlier, I went to a meeting on Monday where somebody had just started kind of exploring those, and they had hours of fun. So for those of you that are a little bit like me, and don't get out much, uh, playing around with these, it can be quite an eye opener. Okay. Also, actually, you can see there on the left-hand side, before I carry on, the red tiles, they're your negatives. So um, you can use them. Okay, all right. Adding fractions. Cuisenaire rods. Now, Cuisenaire rods, I love them. I really, really do. They're so handy for so many different things, and I'll be using them for a couple of different things today. I'll be using them for adding and subtracting fractions, as well as looking at simultaneous equations. Now, the reason I like Cuisenaire rods so much is my students quite like using them. I was worried to start with because I thought, oh, they're going to think they're primary school. Actually, no, they went down pretty well. Um, as mentioned before, they come in units of 1 to 10. So the picture there are the set that I've got. So your ones are white, then brown 2, light green for 3, pink 4, yellow 5, dark green 6, and so on. So the first example that we're going to have a look at is 1/2 plus 2/5. Okay, so what you do first is you pick your units. So you've got your 1 cube for your 1 and your 2 cube for your 2 for your half. And then we have the 2, which is a little red one, and the 5. So that basically represents your fraction. Okay, so 2/5. Okay. All right, so we want to add them. So what we need to do, obviously, is make the denominators the same. So what we do is we take the 2 from the half and a 5 from the 2/5, the two denominators, and we put them on top of each other, as on the picture. And basically, we add and we add and we add until they meet, until they match up. Okay, so in this case, you would have a common denominator of 10, which is 1, 2, 3, 4, 5 lots of these 2s, or 2 lots of the 5s. Okay, now that seems really confusing, but my students got the hold of it fairly quickly, because they got that they just need to add them until they end up being exactly the same length. This one is something that I use an awful lot for my grade 2s, which can struggle with some of the basics. Now, what you do when you have your common denominator is you can either stick with them if you've got enough rods, or you can change them. So in this case, the 10 would be an orange rod. So now let me talk you through this a little bit slower. So we've got our common denominator, which is 10, and which is represented either by 2 yellows and 5 reds, or if you want to make it just one rod, the orange. Now, because we started with 1 red on the bottom, and now we have 5, we also need 5 more of the little 1 units from the half fraction. So you started with 1, you now need 1, 2, 3, 4, 5. Okay, so you basically have 5 1s and 5 2s. And then for the 2/5, we've doubled the 5, sorry. So therefore we need to double the 2 on the top. So we basically end up with 5/10 at 4/10. Okay. Now that seems really, really confusing when you first do it, but it really honestly doesn't take very long. Obviously, then we add them together. What some of my weaker students do is they actually physically put them together. So they can then count them. Um, a lot of them just go, well, 5 plus 4 is 9. But again, they're really, really useful because they lead on so nicely to bar modeling, which I use an awful lot. So using Cuisenaire rods it's a nice smooth move into the pictorial representation. Okay, so let's have a look at another one, which is subtracting fractions. So here we have 2/3, take a quarter. So again, we have our 2 unit over 3. Okay, just like on the picture. And then we have our 1/4, which is the 1 and the 4. And basically, we want to take this one away from this one. Now, I usually start with a little discussion because my students look at that and they go, well, there's no way I can take that away from that because that's much bigger. Um, and it's a really nice starting point for them to kind of explore a little bit. Some groups are more willing, again, than others. But going back to actually solving this, so we do the same thing again. We take the 3 from the 2/3, we take the 4 from the 1/4, and we add and add and add and add until they match up, so same length. So here the common denominator is 12 because we end up with 3 uh, 4s and 4 3s. Okay, as on the picture on your screen, and then we take them away. Now, this can cause sometimes a little bit confusion, especially in this case where we have, obviously we had to quadruple the reds and we had to triple the whites. Um, it can cause sometimes a little bit issues when you take them away if the blocks are different. So what in this case, what I would usually say is I'd ask them, can you do it? Can you just take them away? If they say, well, no, because I've got like a half, then they replace one of the reds with 2 whites and it works fine. Again, looks a little bit confusing, I think, to start with, but once you start playing around with them, oh, I'm so sorry, I got a bit excited there. Once you started playing around with them a little bit, you feel much more confident and you just do it. Now, simultaneous equations is one that has caused an awful lot of issues for my students. A lot of my grade 3s really, really struggle with it. So I started using Cuisenaire rods and bar modeling an awful lot to make it a little bit more visual and a little bit easier for them to play around with. So I've got one here. We've got 4x plus y equals 17. So I've just chosen a random. It's nothing to do with actually what they're worth in units. You could use counters. You could use anything really, any shape, cups, pens for the x and for the y. So I've picked green rods for x and red rods for y. So I've got 4 x's and 1 y and 2 x's and 1 y. And the first one equals 17, the second one equals 11. So once you've laid it out like that, a lot of my students go, ah, yeah, I know. um, to be fair, this is a fairly straightforward one. You can make them a lot more complicated. So you compare the bars to try and eliminate either x or y. In this case, I think we would all go for the y. So we eliminate by taking them away. So we end up with taking away the 2 y's and 2x and 2x. And obviously we take away the right-hand side as well. Now they need to have a little bit of understanding of solving equations, I think, to use these, but if they're quite good at linear equations already, they're certainly worth having a look at for simultaneous equations. So we've now eliminated the y, and we're left with 2x equals 6. So we divide by 2 because we only want 1x, not 2, and we'll find that x equals 3. So hopefully that somewhat makes sense. So we found x, and of course now we need to find y. So what we do is we substitute. So we've got our 4x plus y equals 17. So we got our 1, 2, 3, 4 x's and the y equals 17. We know that x is worth 3, so we can write it underneath. So 3 plus 3 plus 3 plus 3 plus something equals 17. And then we know that 17 take 12 equals 5. So therefore, our red block, or y in this case, equals 5. Okay. Again, if you're not too familiar with these, play around with them. It certainly is worth it. My students found this such an eye-opener. And like I said, you don't need Cuisenaire rods for these. They're great, but you could use dice. You could use anything, really. A box of rubbers and a box of pencil sharpeners will do just fine. Okay, now I've got one more because that has come up before. They say, well, how do I represent a minus? So I tend to use this method. So we've got 2x plus y equals 7, and then we've got 5x minus y equals 14. So instead of adding the y at the end, it goes underneath because that lot minus this one equals 17. Again, it's something that you need to get used to a little bit. Those of you that use bar modeling already, it probably looks familiar. So the y is subtracted from the second bar to get 14. That's why it's underneath. Now you could push them together. They don't need to have gaps. But I try to keep them like that so you can see it better in a picture. So we combine the two to eliminate the y. Now, because there's a minus, I think there's a little bit of a given that you students need to know that if you want to get rid of that, you need to add them. Because 1 plus minus 1 is 0, but yeah, that's a whole other conversation to have with your students. But anyway, we now eliminated the y, and we were left with 1, 2, 3, 4, 5, 6, 7 x's, and we've added the 7 and the 14 together, which gave us 21. So we know that 7x equals 21. And then we don't want 7, we just want 1, so we divide it by 7, which leaves us with 1x equals 3. And then sorry, I've jumped the gun there. And then we substitute again as before. So we know that the x's are worth 3 each. So if we go for 2x plus y equals 7, we have our 2 x's, our y, and a 7. 3 plus something gives us 7. 7 takes 6 equals 1. So therefore, y equals 1. Okay. Now, I am aware that I may have gone a little bit fast at points. You will be getting the PowerPoint, so please don't worry. And also, if you've got any questions, just throw them our way. What we've got is another poll, I believe. Which manipulatives of the ones that we've seen would you use more if you've already started using them but you weren't too sure about them? But which ones will you use in the future a little bit more? or start using. Really, I believe Syra will be open the poll any minute now. So let's see. Oh, we've had apologies for somebody having to leave because it's 5 o'clock. Bless them. You're welcome. So let's have a look. Let's see what you think.
Hi, Leanne.
Hello.
Results are in.
Okay.
We've got 25% on linear equations,
Oh, brilliant.
50% on expanding brackets,
Okay.
50% factorizing quadratics, and 75% on adding and subtracting fractions.
Oh, brilliant. Okay, that sounds really, really good. That makes me really happy because I think if you're a little bit worried about it, especially in FE, they're kind of 16, 17-year-olds. From personal experience, it can be a little bit daunting. I do understand that. But please just go for it. Even if you pick a group that you think, oh, actually they might go for it, and you can experiment on them a little bit. What we've also done is we've done it in our team. So I don't know, I came up with some kind of activity and I got them to do it, and then my colleagues, sorry, and they then feedback to me if they would like it, if they didn't like it, if they think, oh, actually my students are just gonna not do this. So work as a team, play around, you know your groups, have a go. So on that note, I would like to thank you all for joining us for our third online clinic. There is some time for questions if you have any. And yes, please feel free to ask whatever, and I will endeavor to answer them. Okay, so thank you very much for taking part. And if you've got any questions, please, please, please feel free.
Hi, Julianne. Someone's just asked, when is the next online training? And if you can tell them what topic it's on.
Oh my, I can't remember.
That's okay, I'll find that date. So the next one of these GCSE Post-16 online events will be on Wednesday, the 26th of February.
That's the
And
one.
it will be on feedback on the November series with a discussion about the best and weakest areas. I will drop a link as to how you can register for that event in the chat box right now. Well, in 2 minutes.
Thank you very much. Okay. Whilst you possibly are still thinking, we wish. Oh, I totally agree. I could talk for hours and give you 100 more examples. I really enjoy manipulatives, and if you just getting into kind of pictorial representation as well, they're really, really nice. Kind of try this first and then try and draw it. I'm sure I could put a few more examples together and maybe see if they can be emailed out to delegates if you would like some more. There's so much out there. Okay, there is the next post-16 online session link in there as well if you would like to click on that. We are also having a look a little bit later on motivation and engagement. And I think things like manipulatives probably feed into that a little bit, because sometimes my students, I mean, I can't speak about everybody's, but a lot of my students struggle with confidence because it's just been knocked out of them a little bit, especially the ones that have sat it 2 or 3 times. We've got quite a few problems at the moment because the students have kind of run out of steam if they've done a November resit and didn't pass, and then maybe they're sent off a remark. So manipulatives are a little bit of a less threatening way. And like I said, I could come up with a million more ideas, but I think what you'll find is once you start playing a little bit around with things, you come up with loads of ideas yourself, um, and brainstorm with your colleagues in a team. They they're bound to be a lot of ideas out there within your own team. Um, I'm quite lucky. We're all big talkers, so we share. But yeah, any other questions from anybody? Can't see any at the moment.
No, nothing has come through, Juliane.
Okay.
If we give it a few more minutes, if anyone
Yeah.
would like to ask Juliane a question, that would be great. But if not, we'll just finish early.
Okie dokie. I'll stop talking now because I'll go for hours otherwise.
Right, okay. In that
Okay.
case, I think we will say thank you everybody for attending today's session. We hope you found the session useful, and I would also like to extend a massive thank you to Juliane for her support today. Please
Thank
do
you.
take 2 minutes to complete the evaluation online form that will pop up on your screen as soon as the event has concluded. And thank you once again, and I hope you have a very pleasant evening. Thank you. Bye.
Thank you. Bye.